Domain and range of continuous functions.
Okay, some vocabulary, some things that you need to know in order to find the domain and range of graphs is first you need to know that the word domain refers to the x values. Okay. The range refers to y values. Okay. Then if we have a closed circle, meaning just a circle that looks like it's filled in, that's going to be the same thing as you'll either use less than or equal to, or you would use greater than or equal to. Actually, if it's an open circle, meaning it's not filled in, we would use either the less than or the greater than symbols. Okay, the word minimum means the lowest or the least value, and maximum would be the highest or the greatest value. So, greatest. And this one was least. Okay, and the last term that we talk about would be all real numbers. All real numbers. And all that is it's just any counting number. That can include any whole number, whether it's positive or negative. It can include decimals, and it can include fractions. So any number that you can possibly think of would be a real number. Positive, negative, fraction, decimal, whole numbers, whatever it is. Okay, it says, state the domain and range for each graph and then tell if the graph is a function. Write yes or no. If the graph is a function, state whether it is discrete, continuous, or neither. Okay, when I look at this first graph, I see that I have points on the graph, individual points. So this is a discrete graph. I would next check to see if it's going to be a function. Whenever they give us a picture or when they give us a graph, it's really easy to see if it's a function or not by doing the vertical line test. And the vertical line test just means that you take your pen, pencil, whatever you're using, and you draw vertical lines. Notice that as I draw this line, it only goes through one point. Then I'll check another section. It only goes through one point. Over here, 1 point. Right here, it goes through twice. If a vertical line goes through more than 1 point on a graph, it is automatically not a function. So, is this one a function? No, it is not because of the vertical line test here. Okay. The domain is going to be all of the x values for this particular graph. So I could list all the ordered pairs and then pick all the x's out, or I could move from left to right and find out what the x values are for each of the points. So as I move along the x-axis, I see that I have a point here. So here's the origin. I'm going to back up 3, so that's -3 for that x value. Okay. Then from there, I'm going to move, and I find that I have another point here when x is equal to -2. So I'm going to write that down as part of the domain. Then from this point, I'm going to move over some more, and I notice that I have 2 points here when x is equal to 1. So I'm going to put the number 1, and I only have to list it once because no matter what, this is going to be 1 +3 and 1 -2. So either way, the x value is still going to be 1, so I just write it one time. And then from there I move over, and I see that we have another one that when x is equal to 4. So I will write 4 there. We will put these in brackets to show that that's a set. That's all the bracket does. Okay. Then after we finish with the domain, we're going to move on to the range. So the domain were our x values, the range will be our y values. Okay. So open our bracket, and we're going to look at our y values. Now I always want to put these in order from least to greatest, just like I did with the x. So we're going to start at the bottom. and we will move our way up. So our lowest one is right here. So that's when the y value is -4. So we start at the origin, right? -1, 2, 3, -4. So I'm going to write that down. It's -4, comma. Then we go to our next one. So from here we're going to move up, and we see one here. So our y value is -2. Write that down. Then we're going to go to our next one, which is here. So our y value is 0. So if I'm starting at 0, I didn't have to go up any. So that's 0. And from there, we're going to move up some more. Okay. And we see that the y value is 3. And our last one, we're going to go up, and it's at 5. Okay, and then that was the last one, so I will close that set with another bracket. So our range are all of the values of y. It's -4, -2, 0, 3, and 5. Okay, so in this second example, we can see that we don't have individual points anywhere on the graph. We have lines. Okay. First thing I want to do is decide, is it a function or not? So I do the vertical line test, and I'm going to pick somewhere in the middle because it looks like it may not pass it. Right? So the vertical line test means I draw a vertical line and I look to see if it touches more than one point on that vertical line. And this one does. So it does not pass the vertical line test, so it is not a function. So we say no. Now for the domain and range, we're going to look for x and y values that represent this picture. So we have the domain is going to be our x values. The range will be our y values. So when I look for domain, I want to see minimum and maximum values. So if we're looking at our x-axis, I want to say how far does it stretch this way to the left, how far to the right. Here's my boundary here to the left. Okay, that's my minimum value. So if I wanted to write the minimum x value, we would actually be moving backwards 3 units, so it's -3 for my minimum value. Then my maximum value is over here, right? And we see that the maximum value is 3 units from the origin to the right, so I will write a 3. Now we'll look at the maximum y or minimum y value first, which is down here, which is at -4. Right? So if I start at the origin, I move 4 units down, so it's -4. I write -4 here, and then my maximum value is going to be right here, and that's at +3. Right? I move 3 units up from the origin, so I will write a 3 as my maximum value. Now when I go to write my domain, I can't just pick individual points on these lines, right? These lines are made up of millions of points, so I couldn't list all of the values of x. So when I do that, or when I go to write this, I want to take the lower limit and the upper limit, or the minimum value and the maximum value, and I want to use that and write a compound inequality. So all I'm going to use is less than symbols, or less than or equal to symbols. So for my domain, I want to take my minimum x values, because for domain it says we're using x. So my minimum x value is -3, and I want to say that it is less than or equal to x. And then I want to take my maximum x value, which is 3, and write that with an inequality symbol. The way that I choose whether I'm going to use the equal sign or not depends on if there's an open circle or not. The only time I'm going to take away this equal sign is if there's an open circle somewhere. And there's no open circle, so it means that the values that are touching there are included as the x value. So I could pick any number between here, between -3 and +3, and that would be true because x would be, basically if I read it backwards, x is greater than that -3. So any value between here is greater than -3. That is true. And x is also less than 3. So any value between here is going to be less than 3. It does include here because it says the -3 because it says it's equal to -3. And it does include this value because it is equal to 3. So it's all of the values between -3 and 3, including -3 and 3. Okay, for the range, I would do the same thing. I would take the minimum value. So the minimum value is -4. I don't see any open circles here at the bottom, so we will use the less than or equal to symbol. We're talking about range, so we use the y. And then we will take our maximum value, which was 3. And once again, there are no open circles up here, so it does include the value 3. So the values of y, no matter what I pick, from here to here, it's either includes the -4 or anything between that all the way to +3, and it does include that value. So all of the values of y are between -4 and 3, and they do include -4 and 3. Okay, x values are the domain, y values will be our range. First thing we want to look at is we want to see, is it a function or not? I will do the vertical line test to see if it passes. And as I draw vertical lines through my picture, I notice that no matter how many times I draw it, it will only pass through at one point each time. So is it a function? Yes, because it passes the vertical line test. Then for domain, we're going to be looking for x values. So we will look for a minimum and maximum x value. So how far does it stretch this way to the left and how far to the right? I will see if I can draw a boundary. So I draw a boundary here on the left side, right? That's an open circle, so it does not include that value. It's an open circle. Then I'm going to look at what that value was, and that was at -1, 2, 3, -4. So I will write that down as the minimum x value. Then I'm going to look for a maximum x value. So I'm going to look here and see how far it goes this way. And I notice that we have no ending point because this arrow means that it's going to go on forever in this direction. It's moving to the right and it's moving up. So it's going to go on forever to the right and it's going to go on forever up. So there is no maximum value there. So the way I would write that for the domain is I would say that the values of x are going to be greater than, or not equal to, because it's an open circle, so it's just greater than, x is greater than -4. For the range, we're going to look at the maximum and minimum y values. So I will see if there's a minimum y, and there is, right? It's at 1. So I'm going to say there's my minimum value, and then we're going to look for a maximum value. So as I go this way, I notice that it's going to go on forever. Now it does stop on this side, but that doesn't matter because it's going on forever this way. So the values of y will increase forever. So my minimum y value is going to be 1, so I write that down here, and there is no upper limit. So when I write the range for this, we're going to use y, and the values of y are going to be greater than or equal to 1. And the reason I use the equal sign on this one is because it does include these values down here. There's no open circle. Okay, in this picture we want to determine if it's a function or not first. So I will do a vertical line test, and I can see that when I draw a vertical line, it is going to hit more than one point. In my picture, it's going to touch here and here, and if I do another one here and here, there's a lot of different places. Okay, so is it a function? No. Then we're going to look at the domain, so we're going to look at the x values. So we will look to see if there are any boundaries, and there is a boundary on the left, right? That's where my graph stops. There's a boundary on the right, there's a boundary on the top, and there's a boundary on the bottom. There are no arrows pointing on to infinity or forever, so we do have boundaries on all four sides. Now I'm going to write those values down. So for our x values, we're looking at how far does it stretch each way, and this one is at -2 for the x value, so I'm going to write that down. And it stretches to 2 this way, so I will write that down for my minimum x and my maximum x values. So that means everything on the x-axis is going to be between -2 and +2. So no matter what point I pick on this graph or on this picture, it's all going to be between these two values. And so I'm going to write that down as -2, the minimum value, is less than or equal to x, and x is less than or equal to 2. Okay. For the range, we're going to look at minimum y values and maximum y values. Okay, so our minimum y value is 0. So I'm going to write 0 here, and our maximum y value is going to be 1, 2, 3, 4, +4. So since I had a minimum and a maximum value, I would write it as 0 is less than or equal to y, because we're talking about range, which is less than or equal to 4. So all of the values in my picture are going to be between 0 and 4. So no matter where I pick on this picture, it's between 0 and 4 for my y value. Alright, let's look at this next example. First, I want to decide, is it a function or is it not a function? There we go. So I will do the vertical line test. And we see, as I do the vertical line test, no matter where I draw my line, it's only going to go through one time on that. So it will only touch at one point, no matter where I draw that vertical line at. So is it a function? Yes. And what type of function is it? It is a continuous function. It is one continuous line. There are no points, and it does not break anywhere and start a new line. The domain and range, we're going to look at the x and y values. So I'm going to draw a picture frame if I can. So as I look, I see an arrow moving down and to the left. So that means it's going to go on forever, down and to the left. So will there ever be a minimum x value? Will it ever stop going to the left? And the answer to that is no. Will it ever stop going down as I continue along the line? And the answer to that is no as well. Okay, so then we're going to trace it going this way, and we notice that there's no stopping point going to the right. So as we move along the line, we're moving to the right, and it looks like it's going to go on forever. It also appears that it will go up forever. So whenever we see these arrows, it means that it's going to continue in that direction forever. Okay. So was I able to have any upper or lower boundary, or a left boundary, or a right boundary? So the answer to that is no for any of it. So for our domain, we would just write all real numbers. Okay? And all that means is any number that you can possibly think of, we could put in for the domain and it would make it true. Right? So no matter if I'm moving, if I go forever, if I pick any x value that I want, right, 10.5, would it touch the line of here? Yes. So that is a value. I could go to -1 million, and as this line keeps going forever, it would hit it eventually, right? So any number you can think of, all real numbers. Range, it's going to be the same thing, up and down. So it's going to go up forever, it's going to go down forever. So our range is also going to be all real numbers in this example. All real numbers. Okay. Okay, and example number 6. First thing we want to decide is it a function or not? And if I do the vertical line test, right, I'll draw vertical lines throughout the picture. And as I draw it, I notice that it only goes through one point anywhere I draw a vertical line. Okay, so it does pass the vertical line test. So I would say, yes, it is a function because it passes the vertical line test. Okay, now we're going to draw a frame around the picture if possible. So I will start with the left side, and I can see that I have an arrow that's showing that it's going on forever. So will I ever be able to draw a box around the left side? No. It is also going up forever, so will I ever be able to draw an upper box? No. How about to the right? We notice that it is going on forever as well, so there is no way that I can draw a boundary to the right side. And on the bottom, I can draw one right here. Okay, so that's going to be our lower limit for our y-axis, or I mean for our y values, for our range. So if I'm looking at the origin, my lower limit on the y is going to be -1, -2, 3, 4, -5. So I will write that down. -5. There was no value that I could pick for x, so it's all the numbers that way, all the numbers that way. So for our domain, we're going to say it's all real numbers. So all real numbers. And for our range, all we have is a lower limit. So that means all of the values of y are going to be above or equal to that -5. And I say equal to because this is not an open circle, so it says do include this value. If there was an open circle, then we would say do not include that value. But since it does not have a designation of an open circle, we do include that value. So y is going to be greater than or equal to -5. So it's all of the values. Any value I pick for y has to be greater than or equal to this -5 to make it true. So no matter what, as I move up, that value where it would end up touching the line is going to be greater than or equal to that -5. Alright, example number 7. First we want to decide, is it a function or not? So I will do a vertical line test to see, and I just pick this point here, or this line here, and I notice that it touches 2 times. So it does not pass the vertical line test. The answer there is no. For the domain and the range, we're going to draw a upper and lower limit for each side if we can. So we will start with the left side, and I see that there is a lower limit on the left, and that is there. So I will draw my box for this side here. Okay. As I move along the top, I can see that it's never going to end and it's going to continuously move up forever. So I won't be able to put a top on it. We will look at the right edge, and I can see that this is going to continue going to the right forever as well. So I cannot put a boundary on that side. And for the lower limit, so for the bottom, so the minimum value here, I can see that this is going to continue going down forever. So I cannot put a boundary on the bottom either. So the only one that I could find a value for is the x value for a minimum x value, which is at 0. So I'm going to put a 0 here. And that's the only one that I can use. So for my domain, it's going to be all numbers that are greater than 0. So no matter where I move on the x-axis, this is my stopping point. So everything is going to be greater than 0. So when I write that, we're just going to put x is greater than or equal to 0, right? It does include the 0 because there's no open circle here, right? The graph came along and never stopped, and it put an open circle there. So it does include the value 0. So that's why we put the equal sign. For the range, it doesn't have an upper or a lower boundary, right? There's nothing on the top, nothing on the bottom. So that means it's going to go forever in both directions. So we would write all real numbers. And I'm just going to put the number sign. All real numbers. Okay, and example number 8, first thing I want to do is decide, is it a function or not? So I will do the vertical line test. And looks good so far. I get to this point, and it looks like it goes through 2 different points. So is it a function? No. Does not pass the vertical line test. Then we will look at the domain and range for each of these. So I will look for a left boundary. There is none because it's showing that it's going to go on forever. There's no right boundary because it's going to go on forever. So for my domain, I would write all real numbers Now for the range, I notice that we only have 2 values, right? So right here this line goes on forever, but our y value, no matter where it's at on this line, is going to be equal to 1, right? And on this line here, it's going to go on forever to the right. So no matter what value I pick, the y, or for an x, the y value is always going to be 3. So basically I just have a set of 2 numbers. So my range is going to be when y equals 1 and when y equals 3. Okay, in this last example we want to determine if it's a function, so I will do the vertical line test. And it looks like everywhere that I draw a vertical line, I'm only going to go through it one time. So yes, it is a function. Now we need to draw our boundaries if possible. So I will take my pen and there's a boundary on the right side here. There's a boundary on the bottom. To the left, I don't see a boundary because this arrow is going to show that it's going on forever. So there's no left boundary anywhere. And since it's also going up forever, there's no top boundary anywhere. So for our domain, we're looking at x values. And for the range, we're going to be looking at the y values. So for our domain, I don't have a lowest x value, right? They go on forever this way. But I do have an upper value, which is 2. So I'm going to go ahead and write that down as 2. And let's go ahead and make that, I'll write that in red to match, so 2. And then our y value has a minimum value of -2, so I'll write that down. Okay, so when I'm looking at this and I want to write the domain out, I'm saying that all of the values of x are going to be less than that 2. This is my maximum value, so that means everything has to be less than that. So I would write that as x is less than 2. And I say less than because there's an open circle here, and so that means it does not include that value. Okay, for our range, we can see that this is the minimum value here. Okay, so that means all of the values of y have to be above that. So when I write this one out, I would say that y is greater than or equal to, so all the values are going to be greater than or equal to. And I say equal to because that is a closed circle, not an open circle. So the values of y are greater than or equal to -2.